get started. Um, so do you have any particular questions right off the bat with week 6 or 7? We can do week 6 first. Currently, you're the only participant. Maybe we have one more just joined in. So Diana, you can start.
Okay. Only question really I'm having is when you do the problems with the atoms and the molar mass.
Yes.
If you have the if it's something written out that doesn't have the, I knew how I was going to word it. Now it doesn't make sense, but like the way we did back in the first beginning, like if you have a compound,
okay,
a molecule,
okay,
and it's written out like the XeF4.
Okay.
If it's written out xenon tetrafluoride, do you have to write it in the formula before you can work the problem?
That is correct.
Okay, that's why I was messing up.
That's the reason I'm doing that, even though conventionally that when you get to this point in any chemistry course, they don't give you the name, they give you the formulae, but I'm trying to follow the concept map since I have not done anything very much conventional in my other class. In my class, I try to make use of the knowledge, and so this is also another place where you can practice your name to formulae conversion. And
okay.
so you can definitely expect some questions where I may not straight away give the formula, depending on the length of how much calculation involves. Like if the problem is rather time consuming, given that you have 2 hours to complete, I might not, given the complexity of the problem, then I might just give you the formula. But if the problem is very simple, then I'd rather give you the name. So you probably have finished the quiz or the homework by now. Is there any particular areas that you had difficulty with?
I finished the quiz, but yeah, on the quiz, let's see, what did I miss? There was that problem 6, and I worked it several times.
Okay.
And I still come out with the same answer.
Okay, what is it? What is the problem?
So unless I was doing the formula wrong, it had something about 12 grams of iron 3.
Okay. I believe it's iron 3 carbonate, right?
Mm-hmm. I think it is.
And then what does it want?
It was wanting atoms. Well, no, how many carbon atoms?
Okay, how many carbon atoms? Now, I was just in the process of preparing a practice exam, and I was taking questions from the MCAT and the HESI-2, which is the nursing exam, which contains the chemistry. There's 50 questions on that test. So if you're going to take the nursing exam, there's the HESI-A2 version, which is something you will take if you're going to pass the nursing exam. So one of them is the HESI. It's offered by the Nursing Council. And they have 50 questions, and I looked over, a majority of them are slightly worded than the way I have taught you, but at least 80% of those 40 questions were from the material we have learned in this class. So I'm going to try some of those questions as well in my practice exam. So now this is what it wants. As I've always said, first you have to identify the two things that is, one is given and what is wanted.
Mm-hmm.
So you're given grams and you're asked to find atoms. So before you even work out the formula for this, the first thing you gotta have is you have to go from grams to atoms. And whenever you have atoms or grams, the first logical step is to use the molar mass conversion. And then from here, you get moles, and then mole equals 6.022 23 atoms. So this is the conversion, okay? So we're going from grams to atoms. Whenever you have grams, the molar mass is like the mediator. So you have to go to the molar mass conversion, and then you use the mole to atom conversion to get to atoms. Now this is the sequence I have given. Now this is not how it's conventionally taught, but when I taught this course at Kentucky State, students were grateful that I gave this because otherwise they just didn't know where to start, where to finish. Now, this is the first piece of information you should go get after you've figured out what you want and what is given. Now comes the part. I think I purposefully do this just to test how good you are with your week 3 material, which is the homework that was all about naming. Now, this is something I also take some material videos from here and give it to my in-seat people. So I always found these Zoom sessions helpful. So when you write a name, again, there was a question on the nursing exam that was very similar to this. They were asking you to write the formulae for some compounds that are commonly found in foods or additives or preservatives or medicines. So they were targeting one of those areas, and I saw a question very similar to this. So the Roman numeral is tagged to the iron, okay? I'm just refreshing your week 3. The Roman numeral is tagged to the iron, and iron is a metal. So iron 3 gets tagged to the iron, and it's a plus because it's a metal. Now, I did say that, not for you guys, but for my in-seat people, that they have to memorize those 6 or 7 things for the entire course, and we have this. Now, conventional, I prefer to write it this way every time I write it so that I don't get it wrong. Okay? I put it in brackets so that this E doesn't confuse with it. I mean, there's all sorts of confusion that happens in a chemistry class, and to avoid that, I always put my polyatomics in brackets. Okay, so this is where we are ready to swap. So the 3 comes over here, the 2 comes over here, right? This is technically, even if you have attempted the problem multiple times, this is technically what you should have had for your formula.
Okay, that's what I got.
Okay, now what is the mole? Next thing is, first we got to figure out the sequence, and then we figure out the formula. So this is step 1, this is step 2. And what is the molar mass did you get by any chance for iron carbonate? Do you know?
56.
No, the total thing.
Oh, the total. I got 292.
Very good. That's what I had. So that's 292 grams over 1 mole. All right, so that's step 3, is to figure out the molar mass. Okay, now let's go put these things together. So as I always said, there's probably a zillion ways I have seen these being taught. Some of them are very textbook oriented, some are more modernized or more innovative. And I find the tic-tac-toe blocks works the best. So I always put my given information here. Since there's 12 grams, right, of iron carbonate. Since there's nothing, I always put a 1. Because there's only one situation you'll see in week 7 where something will go here, but 99.9% of the time, there's hardly any information. All right, now we follow the sequence. Now we're starting with grams, and to get to this step, which starts with moles, we must end with moles, which is achieved by the molar mass. To get rid of grams, the only way I can achieve that is by putting the molar mass on the bottom and the moles at the top, right?
Okay, did that.
All right, so that's the first step. Even if you don't really make sense of this sequence right away, whatever you're starting with, you cannot have, because we have to have only atoms in the end, right? So grams must go away. Now we're left with moles, and now moles must go away. So a mole contains
then I'll finish it. Don't bother nothing.
Now here's the only difference, because I gave the sequence, and you see me using molecule, because whenever we look at a specific atom in a molecule, instead of it being atoms here, I think I gave alternate sequence. 1 mole is also 6.022 e to the 23 molecules. The only reason being, when you are just asked to find the total atoms, then you go with this. If I ask you to find a specific atom in a molecule, then you would have to use the bottom conversion. They're the same numbers, will give you the same exact thing, but what is designated is slightly different. So now what we have is a situation where our moles have canceled out. Now we are left with a molecule. A molecule must cancel out, and this is a single molecule. This right here,
that's enough.
it's one molecule, right?
It's
How many
hard.
carbon atoms does it have, Diana, on this one?
On the bottom.
3.
All right, so go ahead and put 3 atoms of carbon. Now the molecules can cancel. From here, it's just a matter of getting the calculation right. Let me grab my calculator. I believe I have it.
And that's where I messed up. I didn't put the 3.
I didn't either.
I forgot about the 3. I did the division and multiplied. I didn't put the 3 on her, so it made it wrong.
Yes. So
about the 3.
This is why, I mean, like I said, I was just in the process of preparing that practice exam for you all. And I'm taking questions not from my own brain, but this time I'm taking actual questions. Because if I'm going to publish this work somewhere down the road, I need some kind of generalized questions that is taught across the states. So I cannot just entirely make up a question, because then someone else might be teaching different. So to make that, I'm actually taking questions from the American Medical Council, American Nursing Council, American Pharmacy Council, whatever many councils are there. I'm trying to get a broad number of questions. So now here's the important thing, okay? You want to put all the top in the, again, this is how you do this is entirely up to you, as long as you do it correctly. I personally myself put everything at the top inside brackets and do the calculation in one go. I generally prefer to put everything in one go, like open a bracket, put the exponent 23 and multiply by 3, and then divide by 292.
That's what I left that 3 off.
Yeah. So you
made it wrong.
So you probably got the answer that was missing a 3. That's how, when people in the Nursing Council or the American Medical Council, they may be experts in an area that they are assessing. They don't always do that themselves. That's why they have members of organic chemistry, general chemistry instructors in their advisory board. They have them write the exams for it. Because the doctors don't teach general chemistry students. I do. So I know exactly what my students stumble upon. So when I create a test, I create one choice with the 3 divided and 1 not divided, or 1 multiplied and 1 not multiplied. So that's my 4 choices. Students forget the 3, so they will end up with probably the number divided by 3. So you probably had 2.47 roughly e to the 22. I know my students. I know where they stumble. So that's always one of the answer choices.
Yeah.
When I multiply by 3, I get 7.42 e to the that is the correct answer.
Yeah.
So the only thing really is, I think this is the way I've explained in my videos as well, but you have to determine this. I'm going to highlight this in a different color so that you can see it. It's this right here, and the step after this is not so much difficult. It's the step right here. You have to determine if it's asking for the total number of atoms in any molecule or a element, then you use the top version right here. If it's asking for a particular atom in a molecule, then you use the bottom one. Because that's the only way. If you put mole here, there's no way you can get it into atoms, because this is not, I guess you can technique, but how can both numerator and denominator be moles? That's not possible. So that's why I recommend, if you put atom, you will eventually run into a dead end. Say if you used this top one here, you would see that you have to put the carbon atoms on the bottom, and atoms cancel out. That leaves you with mole, but our answer needs to be in atoms. So if you use the top one, you would run into a roadblock, but again, students don't really write like I do. They write just like this, 12 by 1 times 1 by 292. They write just this. This is completely unacceptable because you have no idea what you're canceling. You have to write the units at the least, if not the name of the molecule, at the least you should write the unit so you know which one you're canceling. If this is the approach, I know that personally because in my in-seat class, I don't lecture. I literally sit with each student and teach them. Wow. So I can personalize and see what that person is doing wrong. And every person has different levels of learning, so they all make different mistakes. So if you just write a bunch of numbers, then you would have no idea what you're canceling. You have to set it up this way. Again, you're only solving one problem. Now, the problem gets even worse when I ask the number of oxygen atoms. That's how many. So we can literally change this question into how many oxygen atoms are there in 12 grams of iron carbonate is how many oxygen are there in the molecule. There's only 9, right? 3 times 3. Now, even worse is the iron. The number of iron atoms is students multiply this 3 into the 2. No, that's only for the carbonate. The 3 is not for the iron, so they actually multiply by 6. So if I ask this question on the test, you can be guaranteed there is a choice where it's multiplied by 6 and not by 2. So if you do the same exact problem for number of oxygen atoms, you just basically keep everything the same. And instead of multiplying by 3, you multiply by 9 and divide by 292. So exact same thing, but so 12 times, I usually put them in brackets because calculators can be fishy a little bit at times if you don't really put things inside bracket. I mean, technically math is math, but sometimes the cosmetic things makes all the difference. So if it was iron, the answer would have been 2.22 or 2.23 e to the 23 atoms of oxygen. And you can do the same for iron, which will be just multiplied by 2. So it's this basic template. I think I used the analogy of a dough or something like that in my video. You have to get this part straight, then everything else is easy. Now, as I said, even if you don't remember this or if you're still confused about this, if you still keep doing like I did, like write the units, then you would ultimately hit a roadblock where you don't know if you should use this or this, and you would notice that you would use the bottom one. Because in this case, if I had put atoms here, and then I put the 3 atoms here, then the atoms and atoms cancel out, I'm left with moles at the top. And that's not what the question wanted. The question wants atoms. So this is the reason why I teach it this way, so students can see which roadblock they would ever hit. So this is what you should have had for your answer on the quiz.
And I had that 3. I knew it said 3, but it said how many, when it kept saying how many carbon atoms, instead of counting, I put 1.
Okay.
But I knew it was 3 because I had the formula worked out right.
Yes, so that's why I said when people request someone like me to write the test for them, we know our participants and what they go wrong with. A doctor or nurse won't write this test because they themselves were students in one point of time. They have never taught a chemistry class. Being a nurse doesn't mean that they will be able to write a chemistry portion of a nursing test. They can write the nursing portion of the test, which they practice clinically in their daily life. But if they haven't taught chemistry, then it's unacceptable for them to write a test. And so when we write a test, we know exactly where our students falter, and we use that in the tests to make you think a little bit. So that's how you do this type of question. And let me bring back.
Before you, I have a question for you on that.
Okay.
When you said like the number 6.8 6.023 e to the 23rd is the molecule.
Yeah.
But then again, in another, like 2 lines down, you had 6.022 e to the 23rd.
They're not hardly any difference, Peggy.
Okay, so it doesn't matter which one I do.
Trust me, that is like taking a drop out of an ocean and you ask a kid, is the volume of the ocean gone down?
Okay.
That level of analogy. I see your question.
I
You're
noticed.
asking me, does it matter? Well, you know, I do this live, so I taught both of these. I see your question, but you know, it's just practice. I cannot. It's like a thief that cannot avoid stealing stuff. It's just I'm so used to writing both of these in my classes. Sometimes I write the 2 with a 3, 3 with a 2.
Okay, but it's either way, it's okay.
It's exactly the same. You will have absolutely, honestly, that fourth decimal, it's this number. If I had written e to the 22 and e to the 23, they're not the same. This is completely different. This answer is different than this answer. This number is not so much important. It's what's next to the e. If you get an e to the 23 and all my answer choices have e to the 22, that means you have done something wrong.
Okay.
This number, and if you noticed, I also round all my values in the periodic table.
Right.
You know, if you say you have a 40.28 and I write 40, even if you write 41, plus or minus 1 will have absolutely no effect on the answer.
Okay, so does that mean we'll get 41 right?
Yes, if you used 41 instead of 40, so this is the gram over mole, right?
Right.
If you use this or the 41, you will have absolutely no difference in the answer choice. Because I don't give 2 or 3 answer choices that are differ by a fourth decimal.
Okay.
That it matters. I would never ever do that because that's not about learning. That's about being finicky on things and
trying to trick. Okay, the other issue I have is with my calculator. I'm getting for that same answer on the problem with the iron.
Yeah.
My answer was like too big to write and no decimals. It was like 741223668. And I was like, okay, I must be hitting something wrong. I did my first few fine, but I don't know what I'm doing wrong. So if
though, when you read your calculators, the E is all the way at the very end. Students don't see that it exists. They forget it and they just see this number. The E is all the way at the very end of the screen. Sometimes it's hard to see. It's at the very, very end of your calculator screen. So read it fully before you write. Again, I did not teach any of your significant figures, so I wouldn't. Your answer will be more, if your answer is 7.402 and I'm getting 7.41, most likely both of these are correct answers. So there's going to be that anomaly always exist when you do calculations. Okay, so I will not give both of these as answer choices. That would be ridiculous. I wouldn't do that. So there will be mostly only one choice in the vicinity of this number. I will not give like both of these and expect you to decide between the two. That's really unacceptable from a test writing point of view. I can't do that.
I appreciate that. The quiz is closed now. Why?
Is it?
Yeah, I tried to do it today and it's closed. It says it closed last night. So I'm screwed.
Okay, I will go back and extend it, okay?
Oh, thank you so much.
Well, technically it's not due until tomorrow. I don't know what happened, why it closed. But
yeah, I saw that. That's why I went on and did it. Because I saw the date was closing.
Okay. It was yesterday. It was saying it was closed yesterday.
At 11:59 on Friday.
That's probably not right. I have no idea. I've been having some technical issues with Moodle, so I don't know if that's attributed to that. I've designed all this way before I even saw many of you in the coursework. Designing, they only pop up as the day comes. So I don't know if I got the date wrong or if Moodle's acting up some way. But either way, thanks for bringing it to my attention right after our ends. I am going to go extend it till tomorrow night.
Okay,
Thank
will the homework be due tomorrow night at midnight,
Yes.
11:59?
Homeworks and quiz, except
Okay.
quiz 7, homework and
Right.
quiz where I've given specific dates. All other quizzes and homeworks are due Sunday night. And then I
Okay.
will tell you the redo when it's due, depending on how fast I can grade these. So the
Okay.
Right.
due date is determined by me, but the initial submission is always Sunday midnight. But
Okay.
bringing it to my attention, I will go ahead and change that extension date till Sunday, right after our session's completed today.
Thank you. I appreciate that.
So I will never actually put two numbers that are so
That
close. That is simply because if you have 10 professors sitting in front of you and you give them that same problem, there's just going to be that 1% difference in the answer, because some like me don't really value that significant figure as much, just round everything up. Some would put every single number in every single calculation. Some would round someplace, not somewhere else. So there's going to be always that element of difference in each person's answer. And I don't think I have yet to come across a test where they give you two numbers that are like fourth decimal difference. I don't think I have personally seen it in years I was a student and I've been teaching. I've never seen that happen. The answers are usually different, contrastingly different choices.
Okay.
So do you have any questions on week 6? Any area that?
Could you do one like where you separate out, like say it's I don't know, like a metal and carbonate or something.
Okay.
And then where you're asking for specific, like the carbon.
Okay.
Can you do?
Yeah,
one of
I actually just worked out that entire problem level.
on that one?
Yeah,
You
that
just-
same specific problem.
Yeah, well, you did it really fast. I mean, I was wondering if you could do it like from the starting point to the end.
Okay, so here's, if I'm correct, I think this is the problem, iron to carbonate.
Well, yeah, or any of them.
And then I'm asking you how many carbon atoms, right?
Right.
I'm going to do this one more time, just with different colors, again, just like I did last time, so you can keep track of the various steps that happens. Well, typically the first step is you have to figure out what is given and what is that you want. And as I've said, atoms is a unit, which some people don't even know, even when they finish a chemistry class. When you ask them, is atoms a unit? Simple question, true or false? You would get false as the answer. That's a common answer, because they never were told atoms is actually a unit, even though they've done a zillion calculations. Most students can't even respond correctly saying atoms is actually a unit, and it is a unit. So we're going from grams to atoms, okay? Now, irrespective of, the problem, there's a general sequence that you follow, which is you're starting from grams and you're going to atoms. Whenever you go from grams, well, first you got to get rid of grams in chemistry before you can really do a meaningful calculation. And the only way you can do that is using a molar mass conversion. You got to go get the molar mass. Now, if you go to a typical chemistry textbook, you won't find the sequence. The information is scattered, but it's not put together in this type of a sequence. So if you look through a chemistry textbook or Google, well, you would never find this image anywhere else. It's not published anywhere. No one's done it this way. So you're not going to find this particular sequence. So if you've tried that, you probably will be out of luck, because it's not something that's done conventionally. So grams to molar mass. And then this will give you moles. That's the outcome of this step. Once you have mole, then you get rid of the mole using 1 mole is, again, I'm going to be consistent from now on, using e to the 23 atoms. Or you can use 1 mole equals 6.023 e to the 23 molecules. Where do you use the top, where do you use the bottom, depends on the question. But you can use either one of these depending on which one you want. Okay, as I was telling Diana earlier, now where do I use the top one? Typically, you use the top one when the question asks you to calculate the total atoms, not any particular element, calculate the total atoms, then you're safe to use the top one. Now, I think I've made this distinction through different problems in my video, but the question is, when the question asks you to calculate the total atoms, would not necessarily saying carbon, oxygen, iron, then you're welcome to use this. Or when you deal with a single element, like silver, just iron, when you deal with a single element, or when the question does not ask you to calculate the total elements in a molecule or element, sorry, it should just be element. Okay, so this is the case for the top part. When do I use the bottom one? Well, when the question asks you to calculate specific quantity of elements, calculate specific quantity of a element. Okay, that is at quantity. What I'm referring to here is atoms. Quantity, specific quantity of a particular element in a molecule. So when do you use the top one? I've already given the explanation. When do you use the bottom one is when you, so this question falls into the category of specific element that is in a molecule. So this is your first step, is figuring out the sequence, because you need to know what is given, what is wanted in this sequence. The second step, I'm going to write it here because I'm going to keep the space for calculation. The second step is calculating the molar mass, because you see, when you have grams, your logical step in any chemistry calculation is to go to moles, because I have not seen any calculation where the answer ends up being grams. At least when you start with grams, you don't end with grams. That's typically the case, the way they set up the problem. So the second step is calculating molar mass. Okay, that's based off of the sequence. That's why I valued the sequence more than anything else, because if you can set up the, again, most of you probably will not have the issue because you're online and you have the resources in front of you, but this is for people that are also watching my YouTube video outside of Midway, or my in-seat people also watch some of my videos. So calculating molar mass, well, that's the problem, because I particularly did not give you a formula. In this case, you have to also determine the formula for iron carbonate, and I'm going to do that over here. Okay.
Okay.
Because I was just telling Diana before a couple of you guys came, is when I looked at the American Medical Council nursing exams, they were asking how to write the formula for given a name. That was one of the questions they had on the test. So I figured, I'm justifying my purpose writing it this way. Now, how do we, this is iron-free carbonate, by the way, I'm sorry. So the 3 is tagged. I'm going to use probably a pink color here just to distinguish. So the 3 is tagged to the iron, and first you got to write, foremost is write the symbol. Fe is for iron, and the 3 is tagged to the iron, and well, whether it gets a positive or negative determines on, that was another question that I ran across. You will be surprised when I give you the practice test how much of that material we've learned is on a nursing exam. So 3 plus, because it's a metal, so it gets positive. Now this is something you have to get it from the list that I gave you. Carbonate is 2 minus, and I write it in brackets just to avoid 2s and 3s getting mixed up. Now we have to swap, and that will give you iron 2. Keep the brackets on 3, 3. This is the formula. And you have to get the molar mass for this compound right here. And if you do, that will be 292 grams over 1 mole.
Okay.
Is that correct?
Yes.
Mhm.
That's what you should have had. Is that correct, Lovell?
Yes.
Okay. So
Okay.
that's the second step. Well, technically, this is also part of the second step, which is you have to figure out the formulae, then calculate the molar mass. That's step 2. Step 3 is actually the calculation, and I'm going to do that in black. Step 3 is actually the calculation that you do. And as I said, there's, depending on who you talk to, which high school the student went to, or which high school the teacher's working in, or where they learned their material, you know, there's probably zillion ways that is probably taught. I'm teaching you the most less cumbersome and easily approachable method. Okay, so, and I always do the tic-tac-toe block method. It's technically not a tic-tac-toe because you have more boxes, but I see that way when I see this problem. You always write the given information in the first top left space. And the reason I'm making this specific way of doing it is so that you don't ever get it wrong. And the given information is a number and its unit. You got to write the whole thing. You cannot just write 12, because that's what leads to confusion most of the time, because you have no idea what you're canceling. And every time you have something at the top, it must be canceled out with something in the bottom. That's the bottom line. Since there is nothing to put on the bottom, I always put 1 in my far left bottom cell on the tic-tac-toe block. So this is the given, and this is just empty cell. You can leave it blank or you can leave it with a 1, but I always leave it with a 1.
Okay. With that, are you supposed to write the 12 grams and then the formula after that?
Yes. Even if you don't write the formula, make sure you get the grams and the number there, okay?
Okay.
I'm not writing the formula here because I want to keep it compact, one screen version. And if I have to write the formula, I have to erase everything else.
Okay.
So, and I want to do the whole thing in one screen. So when a student watches the video later, when they forward or rewind, all the information is one single frame. And
Okay.
that helps with learning.
Keep it straight.
No. Yeah, you don't, if you don't write the formula, technically you should, and I think I've encouraged that. But at the least, you should write the number and its unit. Okay?
Okay.
All right, now the next step is we follow the sequence. Okay, we got this done. We put our grams in the correct box. Next step is put the molar mass to get moles out of it. And the molar mass is 292 grams over a mole. Now, which one goes on the bottom, which one goes on the top is very straightforward. Here we have grams, so the 292 grams has to go on the bottom, and the 1 mole has to go on the top. Now, again, I have not seen many people write it this way. They write it this way. There's a problem. You can ask me, how do I know this? Because this is not the first time I have taught students. I've taught students over a large number of years. And they cannot just translate that into this box or for any calculation purpose. When I write it this way, they think it seems to make more sense. Now we can go get a different color for canceling out. All right, we're done with the first step. Let's go get, now we have moles. Well, we're following the sequence. We're ending up with the right things. We started with grams. We should have had moles at the end of this step, and we did. Now, if you look at the question, it's asking for a specific element in a molecule. That means we have to use the bottom conversion factor. So we put the 1 mole on the bottom, and then the 6.023 e to the 23 molecules on the top. And I explained earlier why we use the bottom one. Even if you forget, Lovell, which one to use, okay? Let's say you use the top one for this, you would hit a roadblock where you won't be able to proceed with your conversion. It's just that simple, okay?
Right.
All right, so now we are at a point. Let's go get our pink pen again and cancel out. If you cannot cancel out and you don't end up with what you want, that means your calculation has a mistake. You don't need me to even proofread it. You can proofread it yourself. If you're not able to cancel out units, then we have a problem at hand. Now we're at the last stage. Now this, I didn't put it here because I don't think I need to put that over here because that adds an extra step. So a molecule, the formulate that we have created, this right here, is a molecule, one molecule. The whole thing is a molecule. And how many carbons does it have? You have to multiply the 3 into the bracket, and we notice there's only 3 carbon atoms. And that's what we want. So let me go get a black this time, or I guess a different color would be helpful. Blue perhaps. So you can see that I'll get rid of the molecule. All I'm left with is atoms. Okay, now you won't find this sequence elsewhere in the book, in your textbook. That's why I didn't even recommend you buying one. Or if you're looking up Google for this type, you would find people doing straight away that bottom conversion I have done. They don't work out the sequence. They just do step 3. Okay, or maybe step 2 and 3, but not step 1. So now I just put everything in a bracket. So it'll be, I usually do it this way so I don't get them wrong. This is the way I even enter it in my calculator. This is exactly how I enter it. Open a bracket, put all the 3 in the top in one go, and then open another bracket. I mean, obviously I have to put the division symbol. Then I put whatever's left on the bottom. Well, there's only 292 because there's a bunch of 1s. If you do this way, the chances of you missing out on a calculation is slim to none. Perhaps none. I shouldn't say slim, but probably none. But if you don't do it, if you just cut slacks or try to be too fast, sometimes calculators do weird things, okay? And if you don't put brackets, you would end up, there's a chance you would end up with a slightly different answer, which may not even be an answer choice that's on the list, because as I said, I know how to prepare a test where one of my choices would be multiplied by 3, one of them would be divided by 3, one of them would be missing a 3, and then one would be just multiplied by a 9, or because they would be seeing carbon as oxygens or oxygens as carbons. It's all visual confusion students have. And I know that from just years of experience. So when I write a test, I know every single student's weakness, and I write the test. Every question has a student's name on it. Every single test question has some student's name or face on it, even though they don't know it's there. Their face is on it, written all over it.
Yeah, I want mine to have, this is Peggy's question. I want to be famous.
I'll remember that. I'll remember that. So are you clear now, Oval? Because I think Peggy and Diana didn't have that problem when I worked it out for them. Since I worked it out for you the second time, do you have any questions on the screen?
No, I think I got it. I've just got to always remember.
Now, let's say I give you so many carbon atoms, and then I have you work out the reverse. So let me get rid of the screen. It's all recorded, so you don't need to write it down. So I'm trying. So let's look at it. Although this was not on the quiz, perhaps something I can test out. So let's say how many grams. Okay, how many grams of carbon, okay, are there in, say, this is all made up, you know, all this is all completely made up. So 3.1, say 10 to the 2 atoms of iron carbonate. This is, I mean, this number itself probably would not make sense to a real chemist, but again, that in that case, even the questions on the nursing exam also wouldn't say it'll make sense to you, because some of these are very abstract. Let's say this is what the given question is. How many grams of carbon are there in 3.0 10 to the 20 10 to the 2 atoms of iron 3 carbonate? Okay. So how do we go about doing this? Okay, let's say atoms of carbon, I forgot this, carbon in iron 3 carbonate. That's what I was really trying to drive across. So that means you are given a specific number of amount of carbon atoms. This is not for iron carbonate. This is how many atoms of carbon do we have, and then we have to go to find how many grams of carbon. Essentially, this is the opposite direction. The train went from grams to atoms in the previous case. This is just the opposite. Either way, well, we do know that this is 292 grams. So let's write that down first, because that's the same problem. That's the molar mass of iron 2 carbonate. Let me get a different pen. Let me do the sequence first, and then you can tell me directly if it makes sense or not. Now we are starting with 3.1 times 10 to the 2 carbon atoms. This is not the entire iron carbonate. This is just carbon atoms. Again, as I always said, put a 1 here. Now we have carbon atoms, okay? But we have to go to grams. That's what we have to get to. And the only way we can do this is there are so many atoms. Well, we are starting with atoms. So I gave you 2 conversion options. One of them is 1.1 mole of 6.022 e to the 23 atoms. That was one. And then the other one was 1 mole equals 6.022 e to the 23 molecules.
Okay. So we want the atoms.
In this case, definitely for now, we cannot use the bottom one because we have an atom sitting right here. So that means we would have to put the 6.022 e to the 23 atoms at the bottom. Okay, and then there is 1 mole. Okay, now here's the problem is, should we put mole or molecule? Well, here it's mole, right?
Right.
Mole.
But we're not, if we put mole here, okay, there is no way we can account for the iron carbonate. So let's say, okay, let's do it this way. Let's do mole. What's the next logical step?
Well,
You have to
Because I want you to find the grams of carbon, right? If you just put the molar mass of carbon, that would be incorrect. Because then we're saying that's how many atoms there will be, irrespective of what the molecule is, right? So this is a little tricky problem. So this is for the carbon, okay? And now a mole contains 6.023 e to the 23 molecules. Okay, because we have to somehow bring in that iron carbonate. This is probably a difficulty of, I don't know, 8 or 10 out of difficulty. So, you know, I probably won't test this, but I'm just asking, see if you understood the sequence. So this is a molecule. Now, a molecule contains 3 carbon atoms. Okay, 3 atoms of carbon. So we can now get rid of the atoms. There's multiple steps to it. So I may have to go further below to complete this problem.
so then we gotta get.
Actually, hang on a second. Let me go back and erase some of this. I guess I could have saved a step. So
Thank you.
I'm going to erase all this and get rid of this. Okay, we're dealing with carbon atoms, right?
Yes.
Okay, so now if we do something, we can minimize the load on our shoulders. What I did is I would have eventually got there, but to make things easy, here we have carbon atoms, right?
Yeah.
How many carbon atoms are there in that formula that we just generated in the previous case?
3.
3, right? This is a molecule. I mentioned that earlier. This is a single molecule. So if you write there's 3 carbon atoms in a molecule, it will save us a step than the earlier version. Okay? This is that step that I did not show in my sequence, but again, that's because if I put it there, then there's no way I can make it generic to all cases. I have to write a sequence for every single compound in the world. That's impossible. So we have to get rid of the carbon atoms, and the only way we can get rid of it is carbon atoms. There's 3 carbon atoms to a molecule. Now this is where your sequence starts. So we are when the earlier case we went from grams to atoms, here we're going atoms to grams. So a mole contains 6.022, and I'm being consistent with what I said too, because I said that whenever you have a specific element, we use the bottom, and that's exactly what I'm going to do. A molecule, so the 6.023 e to the 23 goes on the bottom, and then the mole goes on the top. Okay, this is a molecule of this whole thing, iron carbonate. Okay, so now we have our answer in moles, and then so here we just multiply by the molar mass, which is 292. So 1 mole goes on the top, 292 goes on the bottom, and then we end up with our grams of carbon. Does that make sense?
Yep.
This is exactly just the opposite way of doing it. Again, like I said, I cannot do this step right here. I'm going to circle. I can't do this in a sequence because it's not generic. Each compound is different. This is generic. This is always constant. What I have in the sequence will be always constant. Whereas I cannot do this per molecule, so many atoms in a generic step. I can do it, but again, over a period of time, it will get confusing because every molecule is different. So essentially, we have went from here to there, but when you're starting with a specific element, you have to cancel out that element first before you can even proceed. So if you think about the same exact problem from an oxygen perspective, let me just redo it so I can move this over to the top. It's just this is a little tricky too. Okay, so let's say I have given you the same question, but instead of carbon, say I give you 6.2 e to the 20 or 21 atoms of oxygen. Everything is the same. How many grams of oxygen are there in 6.2 e to the 20 atoms of iron 2 carbonate, iron 3 carbonate? If everything is the same in the above question, I just change the numbers of, so everything is the same, so you always start with the given information. Here you have 6 oxygen atoms. So you start with 6.2 e to the 21 O atoms, that's oxygen. There's nothing on the bottom space, so I put 1. So what goes here in this space here? Here we're dealing with oxygen. We cannot put anything else before we make this circle conversion here, which is for a molecule of iron carbonate, iron 3 carbonate, I have how many oxygen atoms, Lowell? How many oxygen atoms are there in that molecule itself?
3.
3? Are you sure?
Let's see.
You forget something. That's what I will test you.
Oh, okay. It's. Are you still? You're doing iron 3.
So 3 times 3, right?
Right.
You see this arrow right here? That 3 goes into this bracket and gets multiplied. So we have 9 oxygen atoms total. And then that's for a molecule. As I said, this is the only step that's missing in my sequence. Again, I can't incorporate it because that cannot make it generic. That's exactly why I'm doing it this way. So now let's get a different color. Again, whenever you're starting with a specific number of atoms for an element, then you have to first get rid of that. There's 9 oxygen atoms in a molecule of iron carbonate. Now from here, you follow the sequence. We're at this step. We were here somewhere.
Oh, look, the dogs done come over here, Sissy. Look outside. Oh, sorry. I'm sorry.
You're gonna be on YouTube, Diana, all over the place.
Yep.
So 6.023 e to the 23 molecules is a mole. And then, because now we have to get rid of the molecule, now we multiply by 292 grams over a mole, and that will be in grams of oxygen. You would wonder, why are you multiplying by 292 and not by 16 or 12, which is for carbon? That's because we have taken it into account by using the 3 and the 9. Does that make sense, Lowell? Because this is all about ratio. For a molecule of iron 3 carbonate, there are 9 oxygens. So that's why we're multiplying, even though we're multiplying by 292, we are only accounting for the portion of the oxygen or the carbon because we're dividing by 3 or 9. That is the ratio, that is 9 oxygen, which if you multiply by 16 times 9 and subtract from 292, that's essentially what we are multiplying in the end. Even though it looks like we're multiplying by 292, we have factored it using this 9 right here. That's the beauty of math. You would wonder, why are we not multiplying by 16, which is the molecular mass of oxygen? Well, we have somehow indirectly factored that number in by using 9 right here. That's how the math works. So don't multiply by 16, multiply, because this is for iron carbonate, not for oxygen. Keep that in mind. So we multiply by 292, not by 16, because we have factored in the 9 here. If you had not put the 9, then you are not doing oxygen at all. You're just doing iron 3 carbonate. So this step is very critical. If you're starting with a specific quantity of a element, you gotta first get rid of that in your calculation before you go to the actual molecule and finish up the problem. So typically on a test, there will be an answer choice that will be missing this step. And most likely when you do the calculation without the 3 or the 9, you would see a number that matches what's on your calculator and you immediately go for that. And normally that's how we prepare a test, because that test, how much you think about, how much attention to detail you give in a problem. And that's exactly what some of the medical schools and nursing schools want, is how much detail can you give given a situation is very important. And like I said, I worked 2 different scenarios here, and that's how you do. Anytime you're given a specific number of amount of an element, then you gotta first get rid of that element, and then you proceed with the remainder of the problem, which is following the sequence. So this star right here corresponds to this dot here, which is the intermediate step that you have to perform before you proceed with the sequence. So I don't want to put another conversion here because then it won't be generic. I want to only put something in a sequence that's generic. So from here, everything is generic. That will never change, irrespective of what the problem is. So the only accommodation you have to make, whether you're going like in the previous problem or this problem, whenever you deal with a specific element, you have to account for how many there is. And if you don't, you're dealing with a molecule, you're not dealing with a specific count of the atoms. Is that clear, Lowell?
I'm lost. I'll have to go back because I don't know whether I've been doing this completely wrong. I mean, I'd have to go back and look at the answers I've gotten on the homework.
Okay. But look, follow this sequence, okay? The sequence is exactly in my videos too, and I don't change my sequence at all. It's exactly the same thing I've been saying over and over again. So always start with the given information. That's the first thing, okay? Don't put any other number in this box. So let me delete this. And don't put, this box always gets the given information. So this box always gets the given information. That could be anything that's in the question. So if I ask you, how many atoms are there in, so this time let's do just a element, are there in 12 grams of nickel. This is just an element. So when you do the sequence, you're using the top one. So you are asked to find atoms, you're given grams. So this given information is going to be 12 grams of nickel, because that's the only thing that has a number and a unit. That is your given information. That goes right here. And as I've always said, I put a 1 below. Now we follow. It's much easier when you just deal with an element. You're starting from grams. You have to use the molar mass, get the moles out of it. And then from there, you use the, here we're dealing with a single element. So you use this number, not the bottom one, but the top of the two conversion. And then you'll end up with atoms. This is the sequence. And I was looking at nursing exams, and these were all on that test. And so you must know how to do this, so you can do well on that test that you will take. So 12 grams went here. So the next step is, what's the molar mass of nickel? If I go to my periodic table and find nickel, it's 58.69. I'm going to just round it to 59 grams over a mole. You can use the exact value, or you can use a roundup. As I said, it will make absolutely no difference in your answer. I cannot say that any other time, or many times I will say it. It will make absolutely no difference whether you use the exact value in the periodic table or round it one above or below, okay? It will make no difference in the answer. So now we're starting with grams. We're going to atoms. So we need to put the molar mass. We know this is the molar mass. We got to get rid of the grams. So the 59 grams goes on the bottom and the 1 mole goes on the top. That's the first step. Let's go get a different color. You're welcome to actually do it this way. If you have colored pencils, use them, because it really enhances learning, so you can keep track of what you're canceling and what are you left with. I'm gonna go grab my blue back again. All right, we finished just this step right here. We just finished this step. So we just finished this step right here. We got our moles. Now the next step is we have to use the number of atoms. So for 1 mole, I have 6.022023 to the 23 atoms. And that's it. You don't need to do any more else. This problem is finished because it's a single element. It's for a single nickel. All I do is put this conversion factor in. Now I should be able to cancel out my moles, and I'm left with atoms. You should be ending up with what the question asks you. If this does not match what I just circled here, if these two don't match, that means your calculation setup is wrong. That's the only way you can double check it. No matter how many times I teach, in the end, when you do the calculation, you set it up and then you make sure you're getting what the question wants. If these two units don't match, if you're still left with things that are not able to cancel, then you have a problem. That's the best way I can tell you to remember this. Again, you don't have to remember the sequence because you will have it in front of you. So what's the answer, Lowell? Can you put it in your calculator and give me a number? Because that's another problem that some people run into, is the calculator portion of it. I don't know if you have that same trouble with it or not, because I haven't looked at your homeworks yet.
No, I haven't turned mine in yet, and I'm going to have to start all over because I think I've done it all wrong.
Okay, now can you do the calculation for me?
Okay, you take 12.
So here's how you do it. Put the 12 times 6.023 e to the 23. Your calculator might have an EXP. What does your calculator have? Can you show me a calculator on the camera so I can see it?
Yeah, it's got EXP.
Okay, click on the EXP and then hit 23. close the bracket, divide by 59. I love when calculators have EXP because it makes life way too simple than some other calculators where I have to teach them to hit the second button and then get the E value. It's just too complicated. I love it when it has EXP. I mean, it can't be any more easier than that. So go ahead and open a bracket, put a 12 times 6.023 exponent, hit the exponent once, and then type 23, close the bracket, divide by, open the bracket, put 59. In this case, whether you open a bracket or not for the bottom, it doesn't matter because it's only one number. This is all just extra precaution. You don't need to do if you're comfortable with your calculation, but I would never get complacent with my calculator because ultimately your calculator could be the villain in the equation. It's not your knowledge. So what do you get? And the other participants also can do this problem, see what you get, and tell me what you got, and then we can verify that with what Lowell gives us.
Mine's wrong, I think, because I think I have that calculator that you got to teach me how to use.
Okay.
I got 1.1937.
All right, how about I do it? So I write it, and then you guys can tell me if that's the number you have.
I got 1.22.
That's what I got, 1.22 E
Yeah,
to
I
the
got 1.22 E to the 23. Is that correct?
Correct.
That's what I got.
Okay, that's what I have.
So,
All right, Peggy, if you got that, that means you're doing it right.
I didn't get that.
What did you get?
1.19. Here's my calculator. The piece
Oh,
of crap.
1 point. Okay, this number, as long as it's with the vicinity, you're okay. Does this match? Does the E to the 23 matches?
I just put it there, but it didn't match on my calculator. My calculator did that 10 to the 10 again.
Okay. No, what do you
I
get?
know it's supposed to be E to the 23, so.
No, what does your calculator give? Tell me.
Okay, my calculator says 1.193754939 times 10 to the 10th.
Okay, that is wrong. Well, you
Yeah.
can't get this number. So after we finish our session, why don't you take me a close shot of your calculator photo
Okay.
and then send it to me?
yeah, and what I did was I took just because I wanted to see if the way I did it was the same as the way you did it over here on the right, the 12 times,
Okay.
and I did the 12 divided by 59 times the 6 point.
It really doesn't matter. You should still get the right answer.
Same exact answer. So,
The reason I do it this way is because sometimes I have to give a starting point, so I give this. And the reason you are saying this, I mean, both are correct. As long as you use right number of, you're saying this. That will also give you the same answer. It doesn't matter, okay?
right.
As long as you're being consistent and you make sure that it matches one of the answers with it. There is no right or wrong method, and I'm not telling you to adapt a single method, but I have to start somewhere, and this is a good starting point for people that are having calculator issues. So for Peggy, you may have to send me a picture of your calculator so I can see what your calculator screen looks like, and then I can send you the procedure for how to key in, so you can use that for the rest of the remainder of the course.
Okay.
So if you have made any issues because of that, like I said, I'm going to extend that quiz. I don't know why it closed early. I will take care of that after our session's complete. That's the first thing I'm going to do is to make sure that that extension is given.
Yeah, I was going to ask you if I could show you that I can do the calculations even though my calculator isn't getting them right. I mean, I know how to set it all up. It just isn't giving me the right answer.
You used all 3 attempts on your quiz.
I didn't. I haven't even used one yet.
Okay, then when I go back and extend it, when you send me your calculator picture, I can send you quick method of how you can go about it, because I am not going to test. We're not doing anti-log. We're not doing pH calculations. So if I send you that method once, it's going to be the same for all calculations.
Okay, perfect.
Don't even change it. So
now, Lo, I saw you had this on an iPad type thing. Did you download a calculator?
No, I just Google search for a scientific calculator because I realized when he was doing the videos that I needed one. And so
Okay, you can also do one thing, Peggy, is if you have a cell phone, Android or Apple, you can download a free version of a scientific calculator that already has an EXP on it, like the one she has. That makes life way simple.
Yeah, I think I might do that.
Instead of fooling around with even your calculator, there's so many apps. Just make sure the one has an EXP or an EE. One of them should be there in that app. Don't download an app that doesn't have an exponent. It beats the purpose.
so every time you have
So
an E,
download an app that actually has an EXP or double E. If you have one of those, it makes life so simple. You just hit it once and enter the 23, and it just makes things so simple, because things are already complicated. Last thing you want is to complicate your calculation with your calculator, and that's the last thing you want. So are you good with this problem, Lowell, the one we just did?
yeah, I think
Okay,
so.
if you understand this, doing the reverse is not difficult for an element. It's only when you have to do a specific element in a molecule, you have to do like I did on the previous screen. This is easy. Whether we go from atoms to grams in this version for nickel, or from grams to atoms, it doesn't matter. This is easy. You just follow the sequence, because there is no need to do that extra step, because this is a single element. So if you do the same problem, let's do this again one more time, slightly different way.
Yeah, do something different.
So this is not much different. This is going to be a easy reverse mapping. So if you do, we did how many atoms, so I'm going to ask how many grams are there in, again, the way I write might not be extremely consistent every single time, because I hate writing in English first. How many grams are there in 12 grams, 12 atoms of nickel? Okay. Again, like I said, these numbers are probably just made up purely for the purpose of learning. How many grams are there in 12 atoms? So we need to know grams. We are given atoms. So the sequence is grams to molar mass, using molar mass, and then we go to 1 mole equals, again, this is just a single element, so you don't need to even worry about a molecule. That'll give you atoms. This is if you're starting with grams going to atoms. I'm going to switch colors, and this time we're going from atoms. We're starting here. We're going this way, ending up at grams. So it's essentially the opposite, but whatever you do, always put the given information in the first block, and put a 1 below. The top is 12 atoms of nickel. That's it.
That's what's given.
Put the first given information always goes in the top left cell, and then the bottom as a 1. Now we are here. We're at the very starting point. We have to go from atoms. This is reverse. So we have to get moles first. So this is atoms. So the 6.023 equal the 23 atoms goes on the bottom, and the 1 mole goes on the top. Now basically it's just reverse of what we did earlier. So atoms cancel out, we get moles. Now we just learned from our previous case, nickel's molar mass is 59 grams over 1 mole. Now we have 1 mole at the top. We have to put the mole on the bottom and the 59 grams on the top. That's this step is this step is this. That's it. We're done with the problem. We're ending up with grams.
I got that.
That's it. It's only the one that when you're starting with, whichever way you're going, when you're dealing with an element in a molecule, that's when you have to do that element conversion. That's the only difference. That's what I've explained with that other video.
May I ask a question? This might not make sense, but if you worked one that was like the carbonate.
Okay.
Question. And you worked it without taking the 3 out.
Okay.
Say at the end, can you times it by 3 and would you get the same answer?
You should be, technically speaking, yeah, that is correct.
Okay. Because I think that's what I'm doing. That's what I've done on my homework.
Okay, I think, let me see, make sure that I understand your question before I reaffirm that what you were asking is what I was saying.
That was kind of a crazy question.
So you are asking,
If you
say
went,
you have 12 grams of iron carbonate, okay?
Mhm.
And you're asking, I'm asking you how many carbon atoms.
Yes.
You're asking, can I do everything and just multiply the answer by 3? Yeah, you sure can, because that's essentially what we did. So we're starting with 12 grams as a given information, and I put 1. We have to go from the grams to, this is for the entire iron carbonate, okay? So the molar mass that you put in here has to be for iron carbonate, not for carbon.
Right.
So that's 1 mole.
Right.
And you're asking, and then a mole contains, you know, a mole contains 6.023 e to the 23 molecules, right?
Right.
You are asking, can I just stop here, get an answer, and then multiply that answer by 3, right?
Correct.
That is correct.
Okay. That's what I've been doing, and that's why I was kind of thrown off. Okay. And
As
so
I said,
you
that,
also,
I think I even mentioned in the video, the method I show you is like the baseline understanding. Once you get it, how you modify it is entirely up to you. And I think that's your way of modifying it. I put the 3 in the calculation itself. You're doing it outside. You are welcome to do that as long as you remember to do it.
but that way, if you do it that way, then if you turned around and asked about the oxygen, the only thing you're going to have to do is change it to 4.
Yeah, change it to 9, I believe.
Right.
Yeah. Like I said in the video, this is really the way I'm setting it up. It's just a very baseline understanding of doing something. Once you understand it, how you modify it. Well, I know students that don't even do anything. They do the entire problem from the text in the question to their calculator. They don't even do the basic setup. Just like I do. I don't set it up when I do it for myself. I go directly from the text in the question to my calculator. You can do that too. But those students are able to do it because they got the baseline understanding straightened out. Once they did a couple of problems, they figured, okay, I think I'm comfortable not even setting it up. I got the idea. They go straight for the kill and put everything in the calculator. There is a disadvantage to that method is sometimes you get overconfident and you miss something. You multiply or divide. But again, my tests are designed with extra time. I don't design a 2-hour test for 2 hours. I design a 1-hour test for 2 hours. So there should be no test anxiety issues because
I
can be a little relaxed and still be able to finish the test. So this is kind of what we did for entire week 6. So do you have any other problems just pertaining, or any of the other participants, do you also have any problems with week 6 material? Week 6 is straightforward. It's only week 7 that we actually did some. I mean, I can't believe we've done 8 weeks course and did only 2 weeks of math in a chemistry class. That in itself is quality. Chemistry class is purely math right from day 1 all the way till day 20 or 30. So to do just 2 weeks of math in a chemistry class, that itself is different. Typically, all 6 weeks are mathematics intensive. That you would have to really know every single calculation to be able to pass a chemistry class. But when I looked at the nursing exam, I think it is not very math intensive. It is more of, can you read the answer choices and do it qualitatively? And that's what we have done in this class, except for this week 6 and 7, where we have done some math. But I think as a nurse, you should know the basic conversions that might come handy someday. I don't know when, but it'll be handy to have that knowledge. So do you guys have any other final questions for week 6? Of course, we will have another session next week for week 7. And then the very, very final session will be that Wednesday before the final exam. And the quiz is due that night. The only reason I scheduled it that way is so you can ask any last questions that you may have on the quiz and the homework as well on that. and then that exam you will just review many of the concepts that you may, but you will already be seeing a practice exam posted sometime next week that you should at least practice once before we meet for the Zoom session, so you know exactly what you missed out of the practice exam.
Okay.
And then I will also, I don't know if I'm thinking of something is to do it for my own research is I'm going to send you all a practice exam, but the first time you do the practice will be timed and time limited. So you have to complete the test. But if you complete the test, I'll give you some bonus points for taking the test. But that will be like a real test, but it won't be graded, but I will use the grade for my own research. But then again, I will make the same test available for unlimited practices, which you can use for practicing. But the first time you take it will be purely limited time, like a real test, like a nursing exam will be. So I'm taking those questions from the American Medical Council exam, and then the nursing HICE, is that right, Lowell?
What?
HICE A2 or something like that. Is that, you have an exam like that, right?
I don't know. I've already taken the.
You already taken that exam?
Yeah. I mean,
How did you do on the chemistry part?
Well, I was that, you know, I'm already have my associate's degree, so I'm going for my BSN. So.
Okay.
Yeah, so I had to come back and pick up chemistry. Obviously I did okay, but that's been,
Probably did well. Otherwise, you wouldn't be BSN. You know?
Right. No. But you've taught it in such a way that it has been so helpful.
Well, I'm glad to hear that you're doing well in the class. And of course, you're doing well. Maybe you have some self-doubt about yourselves along the way, but I think you're doing well. I believe in you. You are doing well.
Yeah, I'm trying.
The rest of you, do you all have any questions on the material?
Mm-hmm.
I know there's a few of you in here.
No, I'm just having calculator issues. Like she said, you explained it. I can follow this now. I can't make these shortcuts. I do the long thing.
Okay. See, Lowell, now do you see? That's why I did the baseline. Some people stick with the baseline. Some people modify it. Some go to the extreme of reading directly text to math and put it in the calculator. Each person is different. And at the end of the day, you have to do what works for you from the baseline. Don't try to force yourself into the baseline. The baseline is a method that is foolproof, means it works 100% of the time. So even if you have trouble with your method, you can always fall back to the baseline and get the problem right. But if you have a method that you have perfected from the baseline, like you seem to still like the baseline method up to the 3 steps, and then you just want to deviate and multiply it outside, that's fine. So each person's different, and that's why we're doing it this way, so everyone can do it. And then, like I said, for Peggy, in your case, just download an app that's already there. If you're using Android, they have more free apps than Apple does.
Yeah, unfortunately, I have an Apple, and I'm trying, and of course, I forgot my password. So I'll get it.
So, or you can just use like what she did is Google Scientific Calculator on your computer, and it brings up a scientific calculator as a default app that has the EXE on it, and you can use that as well. If you don't want to spend time downloading an app, you can do exactly.
I'm going to need it anyway, so I'm going to get it. So.
But yeah, this is, if you know what we've discussed in this entire Q&A session, this is just different ways of doing week 6 material. I think I dwelt within this over and over again, just different ways. So if you saw 8 questions on the quiz, they're all 8 different vantage views of the same concept. And I was looking just before I started the session today, some nursing exam questions, and they did ask some of the same things that were on the quiz or on the homework or every week. They did ask you the incorrect electronic configuration and then have you flip it. They did that.
What nursing exam are you looking at? Because I have not seen that yet.
It's HICE. I think it's called HICE.
Oh, HESI. Yeah. Okay.
HESI.
I don't have to see that one.
HESI.
Yes.
there's a part 2 of the exam. There's 40 chemistry questions on that exam.
Yeah, I don't have to take that one.
Of course you do. I will probably send a disclaimer with that test because our course is not comprehensive. Technically, you should go through 2 semesters of chemistry to be fully equipped with those exams. But based on what we have learned in the first semester of it, I think you should be able to answer at least 25 out of those 40 questions on that exam. That's still a pretty good achievement if you can do that. But keep in mind, you have not got the full picture of a general chemistry course. I mean, nobody can teach a full course in 8 weeks. That's just impossible. I mean,
Right.
we have slowed down quite a bit to teach 16 weeks of work material in 8 weeks. You would really be cramped. I mean, you just can't handle. I mean, given the fact we are already not doing a chapter method, still that will be too much material to learn in 8 weeks. I don't think anybody will be on the same scale as far as understanding. So if any of you have time and if you're required to take that second semester, that class is not offered as a online, it's only in seat. So if that situation ever comes to you, that you would have to have that separate material, then you still have to sign up for the in-seat class in the spring and take that class. That is only offered in spring, and the general chemistry 1 is offered in the fall. So if any of you are talking to your guidance counselors and they tell you you need to take this material a little bit more advanced, then you have to sign up for in-seat spring semester class and you have to come in person. That's what I'll be teaching, and that's very course intensive. So can you answer all my questions on a HEIS test? Probably not. You called it HEIS, you said?
HESI.
HESI, yeah, you can answer all of the questions from my class because there are some questions from the second semester as well. Okay. I don't think we got through everything because it's just impossible.
Right.
It doesn't help at all learning and all that in 8 weeks.
No.
I mean, it does happen, they do teach them, but I don't know how people can really manage their time learning that much material in 8 weeks. It's just too much.
I can't even take nursing classes on top of it. I don't know.
Yeah, it's just impossible. There is too little time to learn that kind of material. Given that we've just barely scratched the surface in this class as it is, and if that seems overwhelming to you, then that full sequel of courses will be definitely too much in an 8 weeks class. It's just impossible to even cope up with what's happening. So this video has captured everything that you need to know about week 6. If at any point you're struggling, stop and watch the video. It probably has information in one of the many examples we have done.
Right.
I think it will answer any questions you have about week 6. You watch my regular videos or the Zoom session, either of them should have all the answers for you. We worked every corner of the week 6 in this session.
Yep.
We worked every angle. There is nothing left to even tackle. We pretty much solved every variety of garden variety that you can think of. It's all in the video. I would recommend you watch it. And for Peggy, if you just download the app or use the Google.
I got it.
You can just because it comes with the EXP button, and that makes things way simple.
Yeah, I tried it with that question and it works. I got the same answer as I got finally. So
that's good.
Yeah.
All right, guys, I will upload this session, and as soon as I finish with this session, I will go ahead and extend that quiz. I don't know why it closed early, and I apologize if it did, but you will have till midnight tomorrow to turn in your homework and also your quiz for week 6. Okay?
Perfect. Thank you.
All right.
Thank you.
Bye-bye.
Bye.